All right, first thing we're going to work on today is we are on unit 8A.2. It's okay. Okay, and we are going to learn how to graph exponential functions. Okay, graph exponential functions. All right, so your instructions are going to tell you to complete the table of values. Complete the table of values and graph. So on your homework and on all of these kinds of problems, I'm going to give you a table of values. Okay, table of values just means that I'm going to give you numbers to plug in, so you don't have to pick them. Okay, when we did this for parabolas, I told you you could pick any numbers for x. For this kind of stuff, I'm going to give you the numbers that you're going to plug in for x. Okay, we're always going to plug in the same numbers. It's always going to be -2, -1, 0, 1, and 2. Always, always, always. Okay, and then all we really have to do is plug these in. So if I plugged in 6 to the -2, what would that give you? What is 6 to the -2 power? Move it to the bottom, so it'd be 1 over 6 squared, which becomes what?
36. 1 over 36.
1 over 36. So my point would be -2, 1 over 36. Right? Let's plug in -1. 6 to the -1 is equal to what? 1 over 6. Okay? 6 to the 0 is equal what? A 1. How about 6 to the first? 6. 6 to the second? 36. Now I want you to graph this. Okay, so we're going to graph this. It does not have to be perfect. Okay, we're just going to do the best we can. Okay, does not have to be perfect. So if I graphed -2, that's over 2, up 1 over 36. So we're kind of going to be guessing at where that is, but it's going to be pretty close to this x-axis, okay? Pretty close to touching there. Okay? If you plug in -1, -1 up 1/6. So it's up just barely, but not very much. Okay? Then 0, 1, so over 0, up 1. Your next point is at 1, 6, and we're just going to approximate, doesn't have to be perfect. And then finally over 2, up 36. So it would be way, 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 way up here. Okay, if you connect your dots, these are going to go way up. Now, this one on the left side here, this gets really, 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 really close to the x-axis, but it never touches. Okay, it's never going to touch 0. It's going to get infinitely smaller and smaller and smaller. So smaller and smaller and smaller fractions, but it's never going to touch here. Okay? This is what's called an exponential function. Okay? And this is the kind that we call exponential growth. Okay? Exponential growth. And we're going to do some word problems with those in the next notes. But this would be something called exponential growth. Okay? So you might see this in like chemistry or biology. You'll use a lot of these types of graphs to show like bacteria growth or population growth, okay? That type of stuff. So this is exponentially growing. So if I moved even 1 over, it'd be 3, 6 to the 3rd power is 216. So it'd be really, really, really high, okay? This is exponential growth. The other kind of equation that you're going to see is like number 2, and it is y equals 1 over 6 to the x power. Okay, so we just did y equals 6 to the x. Now I'm going to do y equals a fraction to the exponent. We're going to do the exact same steps. You're going to plug into your xy graph, or your xy table, excuse me. We're going to plug in -2, -1, 0, 1, and 2. And then we're just going to plug in to find the point. So if I plug in 1/6 to the -2, what happens there? It flips it, exactly. This becomes 6 squared to the +2. Okay, they switch places. What is 6 squared? 36. Okay, how about if I plug in 1/6 to the -1? What does that equal to?
6.
Just 6. How about 1/6 to the 0 power?
1.
What is anything to the 0 power? A 1. Okay, how about 1/6 to the first power?
6.
Just 1/6. And finally, 1/6 to the second power gives you 1/36. Now, are these the same values that you got, the exact same values when you plugged in the numbers in the first one?
No.
No. Okay, they are actually inverse of one another. Okay, so if you graph these, you're going to see -2 up 36. So this one starts super high. -1 up 6. Let's just guess that it's about there. 0 up 1. Over 1, 1/6. And over 2, 1/36. So this one is what's called an inverse. Okay, it is exactly flipped of the top one. Okay, one is exponentially growing. This one is called an exponential decay, excuse me. Exponential, decay. Okay, so this is one that you might have seen in like chemistry with half-lives. Okay, you have like a particular type of molecule or a type of compound and it's decaying. Okay, it's getting less radioactive. That's usually where we see these. Okay, so you need to know the difference between exponential growth and exponential decay. Okay, this is essentially all we're doing for this unit, or for this set of notes.
Why doesn't the y ever touch?
Why does it never cross?
Yeah.
Okay, good question. It never crosses because no matter what is the value right here? The x value right here is what? 0. Is it possible to plug anything in to get, just say, a number to any value to make it equal 0? Is it possible? Say I have a number there, okay? Let's put a 2. Is 2 to any power going to ever equal 0? Oh, sorry. Is that ever going to happen? 2 to any power? It never happens, okay? It can get smaller and smaller and smaller because it can get really, really close to 0, but it never touches, okay? That's a really good question, okay? Keep in mind that never, ever, ever touches, okay? So, also on this, you need to realize that what do these both have in common? What do you see at these points right here? What is this point on both graphs? Not 0, 0. What point is this right here? 0, 1. Okay, what point is it right here? 0, 1. Okay? 0, 1 will be on every single graph. Okay? Every single exponential graph. And the reason is whenever you have an exponent of 0, it equals 1. So it doesn't matter what you plug in, it's always going to equal 1. What do we call this point right here? Anyone know? You know, we have the x-axis and the y-axis. So what's it called when a line crosses the y-axis? It's called a y what? Intercept. Okay? 0, 1 will always be the y-intercept for any exponential graph, for any exponent graph. 0, 1 will always be the y-intercept for any exponent graph, no matter what. Okay, doesn't matter what you have in the base. Anything to the 0 power equals 1. So your exponent, or excuse me, your y-intercept is always going to be 0, 1. Okay, so we know the difference between exponential growth and exponential decay. Now, someone asked me earlier, how come they never touch? Okay, we know why they never touch, because you're never going to get it equal to 0 or negative. That never makes sense. Okay, so I want you to realize that the graph, we said it's never going to touch. What do we call this right here? This is the x-axis. So if it never touches the x-axis, what does that mean? It never has any what? It has a y-intercept. It always has 0, 1 as a y-intercept. Will it ever have any x-intercepts?
No.
No. Okay? The graph will never touch the x-axis, so has no x-intercepts. Okay? These types of graphs have no x-intercepts, ever. They never touch the x-axis, so they will never have an x-intercept. Okay? These are important things to know. Okay? You need to know the difference between an exponential growth and an exponential decay graph. You also need to know that 0, 1 is always the y-intercept for any kind of exponent graph. Always, always, always. And that there are never any x-intercepts. Okay? There are never any x-intercepts on exponential functions. Questions on how I did that so far? Hopefully not too bad. Okay, next thing I want to go over is I'm going to give you a multiple choice problem for example number 3. Okay, for example number 3. If y equals 4 to the x is graphed. Okay, if y equals 4 to the x is graphed, which value of x produces a point closest to the x-axis. Okay, so if y equals 4 to the x is graphed, which value of x produces a point closest to the x-axis? Would it be 1, 0, -2, or +2? Which value of x produces a point closest to the x-axis? Anybody have any idea how I would start solving this? You can plug them in. Okay? If I plug these in, okay, let's make a little XY table. Here, if I plug in 1, 0, -2, +2. We're plugging into 4 to the x. So 4 to the first gives you what? 4. 4 to the 0 equals 1. 4 to the -2 equals 1/16. And 4 to the +2 equals +16. If you graphed those, okay, if I plotted those, 1, 4 is probably like up here, 0, 1, -2, 1/16, or +2, way like up here at 16. So you tell me, which one produces a point closest to the x-axis? Which is the x-axis? The side to side or up and down? The side to side. This is the x-axis. So which value of x produced a point closest to it? -2. Okay? This would be -2. That's the closest. There. Okay, now, there is going to be a kind of general rule, okay, that will help you so that you don't really have to plug these in every single time. Okay, there's a general rule so that you do not have to plug these in all the time.